Hey, seventh graders, welcome to Module 2, which is all about solving one-step inequalities. Learning target, you will be able to write and solve inequalities. Here we go. So the goal when solving an inequality is to isolate the variable, just like when we were solving equations. We wanted the variable by itself to know what the value was. So we isolate the variable by using inverse or opposite operations. Hopefully that is a term that you remember. Inverse operations are like adding and subtracting are inverses of each other because they're opposite. And multiplication and division is another pair of inverse operations. Step 2, the inequality must remain the same. Step 3, when you multiply or divide by a negative number, the inequality sign is actually flipped. That is just something that we need to remember. It's just an extra step that equations didn't have. So you'll see that in a couple examples here in a few minutes. But other than that, the steps are the same, which is awesome. So let's go through a couple examples. The first one, n plus 5 is less than or equal to 16. So just like the idea of the balanced hanger, I draw my line. I just remember that the left side is actually less than, or it could be equal to 16. So this one is addition. To reverse addition, we use subtraction. So I take away the 5, so the n's by itself. If I do that on that side, I do that on the right side as well. So n is, and I use the same symbol, less than or equal to, and I simplify the 16 minus 5, which is 11. So here's my solution. I'm saying that any number less than or equal to 11 makes this inequality true. I can check it to see if I am on the right track by picking a number less than or equal to 11. So let's just use a check number of 10, since 10 is less than 11. I'm going to take that 10, I'm going to plug it back in to the inequality and see if it's correct. So is the left side still less than or equal to 16? Yes, because 15 is less than 16. So I know with my check number that I chose that my solution set is correct. To graph it, I can just put 11 really kind of anywhere. It's just a sketch of a graph. I use a closed circle, remember, because it's the less than or equal to symbol, and all the numbers less than it would be shaded to the left. Next one. C minus 8 is greater than 14. It's subtraction, so I reverse it by adding 8 to both sides. So C is greater than 14 plus 8 is 22. Okay, so I think my solution is any number greater than 22 will work. Let's try it out. I will pick the number 30 because it's greater than 22. Let's plug it back in. I'll pretend C is the number 30 minus 8. Is it greater than 14? 30 take away 8 is 22. And yes, 22 is greater than 14. Woohoo! So I'll put the 22 here. It's an open circle, and all the numbers greater than it would be shaded to the right. Number 3, 12 times G is less than 48. So it's multiplication. To reverse that, I will divide by the 12. So I have 1G on the left side. And I will do the same on the right-hand side. So I'll divide it by 12. G is less than 48 divided by 12 is 4. Okay, I can go ahead and do a check number just to test it out, but I am just so confident from before that I got it right. Okay, and then it's not asking me to graph it. So there it is. Any number less than 4 makes this inequality true. Number 4, P divided by 3 is greater than 9. So it's being divided right now. So to reverse that, I use multiplication, okay? Because that leaves me with 1p on that side. And then if I multiply by 3 over there, I'll multiply by 3 over here. And I have p being greater than 27 as my solution. Now, inequalities sometimes involve negative numbers. You knew it was coming, right? 7th graders are masters at negative numbers by the end of the year. Remember, when multiplying or dividing, so just multiplying and dividing, not adding and subtracting, when you multiply or divide by a negative, we have to just be sure to flip the sign around. Let me show you. Number 5. -4 times k. So it's multiplication. I am going to reverse that by dividing by -4. And then I have to do it over here as well. So k is, I divided by a negative. So I'm going to right now go ahead and flip that sign around. And then 22 over -4, another name for that would be -5, because 4 goes into 22 5 full times with 2 left over, or I prefer half. So here's my solution. To check it, let me pick a number greater than or equal to -5.5. Well, that's a negative. I'm going to use the number 0 because it's so easy to kind of plug it and check. So let's see if I'm going to plug it into the original inequality with the symbol the way it was. And -4 times 0 is 0. Right? I'm checking to see if this is true. Is 0 less than or equal to 22? Yeah. So I know my solution is correct. I can just pretend -5.5 is here. Closed circle, because it includes that number. And all the numbers greater than it in my solution statement would be shaded to the right. Like that 0, that check number would live somewhere in that shaded area. Next one. S divided by -2 is greater than 5. To reverse the division, I will multiply by -2. Multiply by -2. So then S is, I multiplied by a negative, didn't I? So I'm going to flip that sign around and then simplify what's over there. So I'm thinking any number less than -10 will work for this. Let me check it by using a number less than -10. Let's just do -20 because it's further away from 0. So let me plug that check number in. -20 over the -2. Is it greater than 5? -20 divided by -2 is +10. Is +10 greater than 5? Yes. So I know I have it right. I'll pretend -10 is here. Open circle. S is less than that. So that would be numbers to the left. Okay. Could you go ahead and try these 2 problems? So pause, work them out, then play the video and see how you did. Here are the answers. How'd you do? We're going to wrap up with some word problems. Because remember, that's the other part of your learning target. Carly would like to spend at most $30 on lunches for the week. At most, meaning she does not want to exceed $30. But she doesn't have to spend that much. She could just spend less, right? So at most $30 would be, her lunches would be less than or equal to $30. I know that so far. On Tuesday, Carly had spent $12. Oh, so that's part of the story. Okay, so she spent $12. And then at most, how much money can she still spend? That's like my unknown. So she spent $12 and she can spend a little bit more, right? And then it just has to be less than or equal to 30. I've taken this word problem and I've broken it down into kind of its like a story in a way. Each piece, I just kind of took note of it as I read it. And then this last word problem is the Springfield basketball team needs to raise more than $1,200 to buy new uniforms. If they sell blankets for $30 each, oh, you know what? Let me pause there. More than $1,200 would look like this, right? Greater than $1,200. So if they sell blankets for $30 each, how many blankets? There's my question mark, right? My unknown, my X. How many blankets will they need to sell to reach their goal? Well, $30 a piece and buying so many of them, that's multiplication. So it would be $30 times however many they sell just has to exceed or be more than or greater than $1,200. And that's my inequality that matches this story. And it didn't ask me to solve it. So I'm done. Okay, so your task this week is to solve these one-step inequalities and also look at some word problems and identify which inequalities match those word problems. Happy learning.